Welcome to lecture series on data structures. So in the previous lecture series, we have discussed about list entity and we have implemented list entity using an array. So before moving on to linked list implementation, let us discuss about the advantages of array implementation. There are two main advantages of array, though it has many drawbacks. So one advantage is accessing the elements in an array is very easier, and searching an element in the array is also very easy. Since the elements are at consecutive memory location, searching process is very easy. So these two are the main advantages of array implementation. So as I said before, there are a lot of drawbacks in array implementation, right? So let us see what are the limitations of array implementation. So array store its value in consecutive memory location. That is one major drawback. The number of elements in the array is fixed and it is not possible to change the number of elements. So we will declare the maximum size of the array as we initialize. At the time of initialization itself, we will declare the maximum size of array. So once it is declared, it is not possible to change the size of that array. So this is one drawback. If the array is full, I may not be able to insert a new value. So this is one major drawback of array-based implementation. Next, as we have seen in the previous lectures, insertion and deletion operation in an array is very expensive. So if you want to insert an element is at any particular position in the array, you will perform this operation by pushing all the elements after that position. Uh, you will perform by pushing entire array one position to the right. And if you want to delete an element from particular position, again, you have to shift the entire array one position left. So this both insertion and deletion involves more shifting operation and implies more cost. So these are the major drawbacks of array. So this array is particularly used in programs where you want to store large collection of items of similar data types. So if you want to store data elements of similar data type, there you can prefer using array. So now let us discuss how this array-based implementation differs from a linked list implementation. So as we have seen before, array is a collection of element having a same data type with common name. Linked list is an ordered collection of elements which are connected by links or pointers. So since the elements are stored at different memory location, uh, here each elements will be connected with by link or pointers. So elements in an array can be accessed with the help of index. Whereas in case of linked list, it has sequential access. You may not have any index position to access to. Elements in an array are stored in contiguous memory location, whereas elements in a linked list are stored at random memory or it is stored at the memory space wherever it is available. எங்கெல்லாம் memory available இருக்கோ அங்க எல்லாமே வந்து linked listல values வந்து store ஆயிடும். So it is not stored in contiguous memory location. So insertion and deletion process in array-based implementation takes more time as we have seen before. Whereas in case of linked list, these two operations are fast and it is less time consuming. It is also easy to perform this operation. So in case of array, memory is allocated at compile time. That is, we call it a static memory allocation. If memory is allocated at compile time, we call it a static memory allocation. And in case of linked list, memory is allocated at runtime, and we call it as dynamic memory allocation. There are many types of arrays such as one-dimensional array, two-dimensional array, and multi-dimensional array. Similarly, there are three types of linked list: singly linked list, doubly linked list, and circular linked list. In case of array, each element are independent of each other. There is no dependency among the elements. There is absolutely no dependency among elements in an array, though they are stored in contiguous memory location. But in case of linked list, each node is dependent on each other as the address part contains the address of the next node in the list, which means there is a pointer or a link between each node. So each node is dependent on each other since there is a pointer pointing to the other node. So these are the major difference between array and linked list implementation. So when you're looking at the difference, you have seen the advantages of linked list implementation also. It is much more easier to perform insert and delete operation in linked list when we compare to array. So in the next videos, we will see what is a linked list and what are the various operations that same operations that we perform in array can be performed in linked list, but in a different way. So we will see how we perform those operations in linked list with the help of pointers. So when we discuss about the linked list, we will see all the three types: singly linked list, doubly linked list, and circular linked list, and how the operations like insert, delete, and search is performed in all these three linked lists. We will discuss about the routine also. So keep watching for more updates on data structures. So we will meet in the next lecture series with linked list topic. Thank you for watching.